students. Today we will see the numericals from the topic electron drift mobility in metals. Metals, that is very important. We are not speaking with respect to the semiconductor metals. This is covering in module 1 from electronic materials and device subject. The first question here is calculate the drift mobility and the mean scattering time of the conduction electron in copper at room temperature. So room temperature determines 300 Kelvin. Given that the conductivity of copper is 5.9 into 10 to the power 5. Here important here is the conductivity and resistivity both are opposite. The conductivity is determined by the value sigma and resistivity is determined by the value rho. The density of copper here is 8.96 and atomic mass is 63.5. If mean speed of conduction electron in copper is roughly 1.6 to 10 to the power 6 meter per second, what is the mean free path between the collision? Here what is the question here is what is the mean free path and between the collision. So what is the mean free path? Mean free path, the basic definition is it's referred to the average distance that a moving particle travel between the successive collision. The moving particle, we can take it as an electron. So what is the formula for the mean free path? So it is determined by the value of L. So an electron moves a distance L. L determined by U into tau. What is the U? U is the mean speed of electron. It's not a drift velocity. It's called mean speed of electrons. You have some particular value for it. Okay, tau. Tau is your mean free time. Okay, if you take any crystal, it will not be perfect. It will not be perfect. You have some imperfection due to like a defects, vacancy, dislocation, impurities. Will scatter the conduction electrons. Right. So it is not possible to avoid the pollution, okay, in the material, either in with the field or without field. Okay, so here the question is mean free path. So mean free path is formula is L. I want to find L, and to find L I want to know what is the U and tau. Okay, so U will be determined will be given in the problem, and tau is the value you want to find here. Okay, so we'll solve the problem now. So first we will be finding what is the concentration of electron in the material. So that can be calculated by density of the copper into Na, that is the Avogadro number, divided by your atomic mass. So D is 8.96 and Na is 6.02 into 10 to the power 23 and your atomic mass is 63.5. So if you calculate, you will be getting 8.5 into 10 to the power 22 per cubic centimeter. Now I want to find what is the electron drift mobility. The drift mobility is calculated by mu equal to sigma divided by Q into L. Sigma determine your conductivity. E, small e, determine the charge of the particular electron. N is the concentration of electron. So the conductivity is given in the problem 5.9 into 10 to the 5 and charge is 0.6 into 10 to the minus 19 and N is 8.5 into 10 to the 22. So if you plug in all known values, you will be getting your mobility is 43.4 centimeters square. Okay, so now I want to find what is the tau. What is the tau? You know, tau is nothing but the mu. It is into mobility, the mass of the electron divided by charge. Mu d, the subscript d, determine the drift mobility, the applied field, and m, subscript e, that is the mass of the electron. E is a charge. If you calculate your tau value, Mu already you have calculated in the previous slide, that is 43.4, and your mass of the electron 9.1 into 10 to the minus 31, it's a predetermined value, and charge is 1.6 into 10 to the minus 19. If you calculate, you will be getting 2.5 into 10 to the power minus 14 seconds, that is a tau. I hope you understand this problem. We have calculated the tau. Right. So once you know the tau, you know the tau is nothing but a mean free time. It's a mean free time between the collision. Right. Now I want to find what is your mean free path. What is the formula? L equal to mu into tau. Sorry, L equal to u into tau. What is the u? U is the mean speed of the conduction electron. It is given 1.5 into 10 to the 6 meter per second. So you multiply your mu into your tau. You will be getting 3.75 into 10 to the minus 18 in terms of nanometer, 37.5 nanometer. This is a free path. It's a mean free path. It's the average distance that the moving particle is traveled between the collision. So you can see that is a L. It is a L defines that is the average distance that the particle is traveled between the successive collision. Okay, this is the thing you understood. Then the next problem is a drift velocity and mean speed based problem. The question here is what is the applied electric field, okay, that will impose the drift velocity equal to 0.1 percentage of the mean speed, that is mu, that is 10 to the 6 meter per second of conduction electron in copper. What is the corresponding current density, that is J, current is I, through a copper wire of diameter 1 millimeter. Very simple problem. What is the formula for drift velocity? We know that V, that is a drift velocity defines, it's nothing but a product of mobility in the electric field. What is the mu? It's a drift velocity. It's a drift velocity. So we have determined in the previous problem, that is 43.4. With that we have substituted here, and Vdx it's given equal to 0.1 percentage of the mean speed. Okay, that means 0.1 divided by your 100 into 10 to the 6. This is a 0.1 percentage. Right, so we want to calculate by 0.1 divided by 100. The mean speed is 10 to the 6. You want to multiply. So we will be getting 10 to the power 3 meter per second. So now we calculate what is the E, the drift velocity divided by mu. What is the drift velocity you have calculated? 10 to the power 3. What is the drift? What is the mobility you have calculated? 43.4. It is found out to be 2.3 10 to the 5 volt per meter. Now I want to find what is your current density. What is the current density formula? J equal to sigma into Ex, that is the electric field. The conductivity, the copper, is 5.9 into 10 to the 5. It's given in the problem. Consider it is given in the problem. So what you want to do is, you want to multiply both the value. You will be getting the current density. You will be getting the current density. So that is found out to be 1.5 into 10 to the 13. So you know that J is nothing but a I by E. So I is the current and the area. So ampere per meters per square.